Geometry family. Today we are going to do a lesson on similarity proofs. And the good news is, if the word proof gives you a little bit of anxiety, similarity proofs are some of the easiest proofs that we do because they are very predictable and they often roll together in the same way. Okay, so there's only one day of this lesson because it's really that predictable. There's not that much else that builds onto it. So stick with me and we will get through it. Now, normally when we do proofs like triangle congruence proofs, we had ASA, SAS, SSS, HL, and what's another one? AAS. Okay. The nice thing is for similarity, there's not that many. The only three similarity theorems that we have from the other day are angle-angle similarity, side-side-side similarity, and side-angle-side similarity. But the thing is, when I'm doing a proof, I don't know how long the sides are. So I can't do those proportions to see if the sides are proportional. So my proofs do not normally involve those last two things. So when we do triangle proofs for similarity, we are always going to look for angle-angle similarity. Now, why is that good? Well, that means all I have to look for in the diagram are two pairs of congruent angles. And once I have that, I know the triangles are similar. I don't have to fish around for sides and try to figure out why one thing matches. None of that. I just have to find congruent angles. And congruent angles pop out of the page really easily because we have like vertical angles or alternate interiors or corresponding. We can usually find angles pretty quickly. So let's do that. In this first one, it says, given that KH is parallel to JI, prove that the triangle GKH, the top one, is similar to GJI, the entire thing. Now, we've already talked about the fact that they are similar. Now we're going to prove it, in a proof. Well, let's see. This proof is going to start the same way all our proofs do. I'm going to restate the givens. KH is parallel to JI, and that was given to us. Now, let's use that given. Well, if KH and JI are parallel lines create either alternate interiors, if I can find a letter Z, or congruent corresponding angles, and that's what I have here. This angle right here and that angle right there are corresponding angles between parallel lines, which makes them congruent. So for number 2, I'm going to call this angle 1 and angle 2, and say angle 1 is congruent to angle 2, because if lines are parallel, corresponding angles are congruent. All right. And in fact, there's another pair of angles that we could also say are congruent. I've got these corresponding angles over here. That's 3, that's 4. So I can also, on the same exact line, say angle 3 is congruent to angle 4, because that's another pair of corresponding angles. And guess what? I just found 2 pairs of congruent angles. I found angle, angle, which means I'm done, and I have enough to say that triangle GKH is similar to triangle GJI because of angle-angle similarity. And remember, angle-angle similarity says once you get 2 pairs of congruent angles, the triangles have to be similar. All right, let's do it again. MQ is parallel to PO. Prove that these 2 triangles are similar. All right, well, let me start again with my given. Why did I write A? I don't know. MQ is parallel to PO, and that is given to us. And if these are parallel, I don't see corresponding angles, but you know what I do see? I do see some alternate interiors because I see a nice letter Z right here. So angle M is congruent to angle P because if lines are parallel, alternate interior angles are congruent. And then I see a bow tie here. So the other type of angle that I see is congruent are these 2 right here. So I can say angle MNQ is congruent to angle ONP because vertical angles are congruent. I have 1 pair of angles. I have 2 pair of angles. I have angle-angle similarity now. So now I know triangle MNQ is similar to PNO by angle-angle similarity. Now, before I move on, there may be some of you saying, wait a second, Ms. River, did you have to use those vertical angles? No, I did not. I could have also said that Q is congruent to O because those are alternate interiors. But I just wanted to remind you that I could use that vertical angle theorem. And you know what? Even in this other one, if I decided not to use the two corresponding angles, I could have used the reflexive property on angle G because angle G is shared by both. All right, but I didn't, and that's fine. Now, why do we even care about similarity proofs? Well, we care about similarity proofs for the same reason that we cared about angle-angle similarity in the first place. Once you know that triangles have congruent angles, you know that all those sides are proportional, which is a great solving mechanism to find, values. So we can do that whole proportionality thing in a proof just like we did it by hand, except instead of using numbers, we just set up the proportion using like the names of the sides. So let me show you what I mean. Once triangles are proven similar by AA, it follows that corresponding sides are proportional. Okay, so what that's saying is, if you give me that I have this BD, just means that BD is one big straight line, AE, that means AE is one big straight line, and I was given that angle B is congruent to angle D, prove that AB over ED equals BC over DC. Wait, what? AB over ED. Okay, so those would be corresponding parts. BC over DC. Oh, those would be corresponding parts. What they've done is they're saying prove that this proportion is true. And in my head, I'm thinking, well, that proportion would only be true if the triangles were similar. So I need to prove these triangles similar and then state that the proportion is okay. So let me show you how to do that. I'm given all this information. Great. I see a bow tie. So the next thing I'm going to say here is that angle BCA is congruent to angle ECD because vertical angles are congruent. Okay, and I'm going to write vertical out because that's a word a lot of people spell incorrectly. Vertical angles are congruent. And then I look at the picture and I realize I have two pairs of congruent angles for each of those triangles. So triangle BCA is similar to, now I need to be careful of how I write this order. BCA would be similar to, well, B corresponds with a D, so that'd be DCE by angle-angle similarity. Nobody told me to write that down, but I have to, honestly, just because I can. I found two congruent pairs of angles, so I know I have similar triangles. So I'm going to write that down. And then after that, I'm going to write the proportion that they wanted me to write. And the justification for that proportion is the following. Corresponding sides of similar triangles are proportional. All right, corresponding sides of similar triangles are proportional. And we do pull an acronym out of that. CSSTP. And that mouthful of letters, that mouthful of consonants should remind you of another mouthful of consonants that we had before, CPCTC. This is the similarity equivalent to CPCTC, okay? Now, what do I need you to see from this? I need you to know that if, in a proof, you are ever asked to prove that sides are proportional, you need to think about that proof backward and say, wait a second. I'm only going to have proportional sides if I have similar triangles. So let me get there first and then finish off with proportionality using CSSTP. All right, so I talked through it. Let's do it again here. This one says, oh, nuts. It doesn't say prove that things are proportional. It says prove that you can multiply things together. Why would I be multiplying things together? I'll tell you why. If I take this thing that says I've got a given, and I'm supposed to prove that I can multiply stuff. In this unit, why have we multiplied? Well, we've been doing a lot of cross multiplication. And if AD got multiplied by BC, that means AD and BC were diagonal from one another. And it doesn't matter which one goes where, they just need to be diagonal. And it would also mean that AB and DE were diagonal from one another. And so if that's true, which it is, I now have the same setup that we had in the last problem. So if you're asked to prove that things can get multiplied, you're really being asked to prove that things can get divided. And if you're being asked to prove that things can get divided, that means you're being asked to prove, you're being asked to prove that two triangles are similar. So there's a lot of sleuthing that goes in before you even start a proof like this. All right. So now, let's actually do the proof. Shut up, Mrs. Verber. Let's get the problem done. It says given C and DEA are right angles, prove that I can do the product. All right. Well, I'm going to start proving more angles. So if C and DEA are right angles, then C and DEA are congruent because all right angles are congruent. All right. And now I want to try to think about the two triangles here that I'm supposed to make similar. I've got this one right here, and then I have the big one. Well, you know what? Those two triangles tucked together in that corner there, they tuck together at angle A. Angle A is congruent to itself by the reflexive property. When you have two triangles that tuck together like that, that's the reflexive property for angles. Reflexive property. And so if I unscribble that, I've now proved that A is congruent to itself. I have this right angle here. I have two pairs of congruent angles, which means I have two similar triangles. All right, now I need to name them here. So I'm going to call the first one ADE. And if I name that ADE, it went from A to the right angle to the other letter. So A to the right angle to the other letter would be ACB. If I know triangles are similar, then I can set up a proportion. That's the thing that I have in blue up top. How can I do that? Well, if I have similar triangles, proportions are going to be true as long as they're, proportions of appropriate sides, and I know that they are. And this is CSSTP. Corresponding sides of similar triangles are proportional. I want you to write an AKA here. AKA, if triangles are similar, matching sides are proportional. That's what that really means. CSSTP in layman's terms is if triangles are similar, their matching sides are proportional. And then if I have a proportion, I rarely leave it like that. I usually cross multiply to help me solve it. And that cross multiplication would be AD times BC equals AB times DE. And that's through cross multiplication. Or sometimes you'll see this written as the cross product property. I don't care which one you call it. You just need to know that you cross multiply, and another word for multiply is product. Okay. This is what all similarity proofs look like. You find an angle, you find another angle, well, a pair of angles, another pair of angles. Then you can prove the triangle's similar. And then if you want, or if you were told to, after you prove the triangle's similar, you can set up a proportion. And if you want, or if you were told to, after you have the proportion, you have a product. So you must prove that the triangles are similar first before proving corresponding sides are proportional. And then you have to prove that corresponding sides are proportional before you do the cross product property. All right. I think this video is long enough. What I am going to do is also have a homework follow-up here, but I want you to give this homework a shot and do the best you can, and then I will go over that a little bit later. So on your homework, what I really want you guys to do is make sure that you can do page 42. Page 43, less stuff is given to you, so that might be a little bit more of a stretch, but I think you can do it. but make sure you know how to do 42 on your own. I hope everybody's having a good day and continues to have a good day. Toodaloo.